Hello everyone, welcome to Royal Palace online classes. Today let us discuss one of the application of addition of vectors, that is motion of a boat in a river. Motion of a boat in river. Motion of a boat in river. First, let us discuss case 1. Case 1. There is a river flowing like this. See, there is a river flowing in this direction. Velocity of river, I will take it as VR bar. Okay. There is a boat this is a boat which is traveling in the direction of river, that is, this you will take it as velocity of boat. Okay. In this case, what happens? You are flowing, you are going in the direction of water velocity. Now, what is the net velocity? Net velocity of the boat is equal to, resultant velocity of boat is equal to velocity of boat plus velocity of river. This is an addition, example for an application of addition. Now, what is angle between these two? Magnitude you can calculate. Magnitude is equal to root of Vb square plus Vr square plus 2Vb Vr cos 0 according to parallelogram law of vectors. Now, this you will get it as Vb plus Vr. Vb plus Vr. Therefore, when you are going in the direction of water velocity, your velocity will become more. Boat velocity, boat will go very fast. Velocity of river is added to you. Next case 2. Case 2 what happens? I am going opposite to the river direction. Again, this is the river. This is the velocity of water, that is, I will take it as velocity of river. Velocity of water, this is this direction water is flowing. VR bar. Now, see, my boat now it goes in this direction, opposite to the river velocity. Opposite to the river velocity. This is called upstream, this is called downstream. There is another name for this, downstream. So, upstream, resultant velocity is equal to, again you have to add two vectors, velocity of boat plus, first you will take in vector form, velocity of boat plus velocity of river. Okay. Now, if you take magnitude, you will get root of Vb square plus Vr square, Vb square plus Vr square plus 2Vb Vr cos 180. cos 180 degrees. So, this is equal to Vb minus Vr. Your net velocity will decrease. This is called upstream. This is called upstream, right? Okay. This is about two cases. These are very simple. This is our common experience. When you are going, suppose you are going on a cycle, in the direction of wind, your velocity increases. Downstream, that we call it as downstream. When you are going upstream, your velocity decreases. This is common. You already know. Just like freely falling body, velocity increases. Vertically projected body, velocity decreases. You are going opposite to the direction of acceleration. So, here you are going opposite to the direction of river velocity. This is the condition. These are very simple. Next, case 3. This is important. Case 3 and case 4. You will get most of the problems from case 3 and case 4 only. Now, let us see what happens here. In case 3, observe carefully. Case 3. Case 3, we are crossing the river from one end to, let us take, you are at a end A. You want to reach exactly opposite point B. You are crossing, you are going in this direction. Previously, you are going in the direction of water. Now, you are crossing the river. Now, let us see what happens when you are crossing the river. Okay. Now, this is the velocity of boat. This will be the velocity of boat. Now, this is the velocity of river. This is the velocity of river in this direction. So, what happens here? You are aiming towards the opposite end, but as time progresses, your velocity of boat is getting shifted because of velocity of river, and you will reach, instead of reaching exact opposite point, you will reach another point C. The reason is, you can observe here carefully, this is your velocity. At each and every point, water is pushing you towards right. So, here it is pushed towards right, here also right, here also right, like this at each and every point you are pushed, and finally you will reach here. So, this was your velocity, this was river velocity, you are in the boat, this was the boat velocity, this is boat velocity, but this is the resultant, this is the resultant now, V is the resultant. Understood here? This is also an example for addition. See 1, 2. Now, I can draw one more line here, which is nothing but Vb, here which is nothing but Vr. Now, again go back to your parallelogram law of vectors. You can see here two vectors Vb and Vr represent. This is a parallelogram now. A, this you take it as D. AB, CD is a parallelogram. AB represents velocity of boat, BC represents velocity of river, CD represents velocity of boat, AD represents velocity of river. So, if you observe this, this is a parallelogram. Two vectors are acting at the same point, representing two sides of a parallelogram. Then the diagonal passing through the same point is nothing but their resultant. So, that resultant is nothing but V. Now, what is the resultant you can calculate? V bar is equal to, again same formula, Vb bar plus Vr bar. That means here, instead of going to point P, you are reaching C. Okay. VB plus VR. Now apply, find magnitude, apply it, can apply parallelogram law of vectors. Angle between VB and VR is exactly 90 degrees. Angle between VB and VR is exactly 90 degrees. So VB square plus VR square plus 2VB VR cos 90. So what you are going to get? This you will get it as VB square plus VR square under root. Okay, this is the resultant velocity. Now thing is here, what they will ask in the exams, in problems, this is most important for solving problems. What they will ask is, actually, this is the resultant velocity. B to C is called shift, lateral shift. This is the shift you have got. Shift means instead of going to B, you are reaching C. Now they will ask, what is the time taken to cross the river? Time taken to cross the river is, time taken to cross the river. For that, you can draw one more diagram. You can draw one more diagram for calculating time taken to cross the river. If width of the river is D, width of the river is D, this is A, this is B, this I am taking it as D. Okay. B to C I will take it as X, X is the strip, X is the shift. Now A to C will be, according to Pythagoras theorem, you will get root of D square plus X square. Okay. Now observe these two triangles, observe these two diagrams. What is the velocity in the direction of AB? Time taken is equal to distance along the direction AB and take the velocity. What is the velocity which is along the direction of AB? It is VB. So therefore D by VB is the time taken. Within that same time only, person has suffered this much shift. Which time? Suppose you started your journey at t is equal to 0. By the time, suppose if water is not there, you should have reached B. Within that time you reached C. So time taken per journey is always same. So again I can equate this to x by VR. What is the velocity in that direction? VR. So here you have to understand carefully. We are taking the displacement along direction AB. In the same direction you take the velocity. So d by VB is equal to x by VR. Or this also you can write it as equal to root of d square plus x square divided by root of VB square plus VR square. This is the time taken. Okay. This is the time taken. Now this is your displacement is more. AC is greater than AB. This already you know, because hypotenuse is greatest side. AC is greater than AB. So this is called longest path side. Longest path method. The longest path. Okay. You are going in the longest path. And the next time what you will do? Now you understood. When I head towards the opposite edge, opposite end, I want to reach exactly opposite. But you reached C. That means instead of your home, you reached your neighbor's home. Then you understood, you got some experience. So I want to reach B only now. No need to come back, because after coming to C, again you have to go back like this. You don't want to go back. Directly you have to reach B. Exactly opposite point you have to reach. So if I go in exactly opposite point direction, I am reaching C. So now what I will do? I will starting only I will take some angle like this, so that I will reach B like this. So this is what you have to understand here. So before knowing this condition, you went from A to B. Instead of going from A to B, you went C, and from C again you are coming back. So instead of avoiding that confusion, instead of avoiding that traveling back, what we will do? We will go in a different path. First only we will take can observe here, first only the person will take some angle. First only the person will take some angle. See, this is the river direction, velocity of river direction. The person, now instead of going straight, now person will take head towards another point. He will head towards another point like this. This will be the velocity of boat now. This is the velocity of boat now. Now what happens? Water is pushing this. Water is pushing this each and every point like this, and finally there is a possibility to reach the exact opposite point. This is A. You are heading towards another point. So this I will take it as C. Okay. Suppose you are going straight. Straight, what happens? Water is pushing you towards right side, and finally you reached towards right. So I want to go straight like this, but I reached other side. So next time what I will do, I will head towards this direction. Finally I will reach to the straight direction. So now you can observe here, this is the velocity of boat. This is velocity of boat. This is velocity of river. Now directly by using Pythagoras theorem, you can find. Otherwise, again you have to construct one parallelogram like this. Okay, you have to construct one parallelogram like this. You have to construct one parallelogram where VR is this. You can construct one parallelogram like this. This will be the diagonal. Okay, you can construct like this. One parallelogram you can construct. This is the condition. If you construct one parallelogram, this is VB, this is also VB. This is the diagonal now. So this also you can do, or directly you can use Pythagoras theorem. So this will be, by using Pythagoras theorem, VB square is equal to, hypotenuse square is equal to VR square plus V square. This I will take it as V. This is the resultant velocity. So what is the resultant velocity in this case? Root of VB square minus VR square. This is the resultant velocity. Understood? Now again you see the diagram. If you want to calculate time here, in previous case the velocity along AB was VB, that's why you took D by VB. Now here what is the velocity along AB? You can just observe, it is V. So therefore D by VB square minus VR square, okay, under root. So this is the velocity. Okay, this is the formula for time. Now observe these two times. This is D by VB. This is D by VB square minus VR square under root. Means this is smaller when compared with this. VB is greater. So time taken is short. So this is called shortest time path. This case is called shortest time case, where you are getting D by VB. Previous case, case 3. Case 4 is shortest displacement, because you are heading towards AC, you are reaching along AB. So this is longest time and shortest displacement, shortest path or shortest displacement path. Okay, this is the condition. So this is the motion of the boat in river. So this points you have to remember. Just you have to take the velocity in the direction of displacement. That is the only point what you have to remember. And this is an example. This is an application for parallelogram law of vectors. That is addition. Parallelogram law of vectors. Parallelogram law. It is an application for addition. So what they will ask? They will give the condition. Boat want to cross the river in shortest time path. What is the time taken? Means D by VB. Boat wants to cross the river in a longest time path. What is the time taken? D by root of VB square minus VR square. So this is the condition. So sometimes they will ask, after reaching sea, person is traveling with velocity of 10 meter per second, what is the time taken? So like that they can ask the questions based on the motion of a boat in a river. So this is about the one of the application which will come across in competitive exams, and I think in NCERT also one or two questions are there based on this concept problems. So this is the condition, motion of a boat in a river. You have to remember upstream, downstream, and shortest time path, and case 3 is shortest time path, case 4 is longest time path. Okay. Thank you everyone for joining me.